Okay, all right. So, hi everyone, welcome back. Today we are going to solve another problem of LeetCode. So, the problem name is jump game. So, let's go through the problem once. So, here we are given an integer array nums, and you are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Okay, and we have to return true if we can reach the last index or false otherwise. Okay, so going by this example 23114, so we have to tell our whether we are able to reach the last index of this array or not, and the element present at a particular index denotes what is the maximum jump we can make from that particular index. So here the value is 2, which means from here we can either reach 3 or 1. And if we are at this particular index and this index has value as 3, which means we can make a jump of 3 from here. So we can reach either this one or this 4, starting from this 3. And ultimately we have to find out whether we can reach the last element of the array or not. So this looks like a very basic problem of the arrays along with some greedy approach as well. So let's try to see what can be done using the greedy approach here. So this is the array and these are its indexes. So here the basic approach, the first approach that comes to our mind is like somehow we can maintain what is the maximum index that we have reached till now. So while iterating over the array, what we can do is we can maintain one variable, and that variable will contain the value that we are able to reach this maximum index till this point of time. So suppose we started iterating over the array from 0th index, and this 0th index value has 2. So let's call a variable max index visited till now, right? So it will, suppose initially will have a value of 0. So when we are starting iterating over the array, so the value present here is 2, which means we can make a maximum jump of 2 places from here, which means we can either reach here or here. So the maximum value is 2, like the maximum index value is 2, so this value will be updated to as 2, right? So when we now reach this index, first index, the value at first index is 3. So what is the maximum index we can reach starting from here? So that will be the index value of the current one, which is 1, plus the value present at that index, which is 3. So 1 plus 3 is 4. So starting from this index we can reach this index directly. So this value 2 will be updated to 4. So one condition we can basically put is that if we are able to reach the last index of the array in the process, then we basically return true from there itself. We don't have to iterate over the rest of the remaining array. Otherwise, we keep on iterating over the array. Right. So let's write the logic for this. So let's create one variable which is initialized to 0 initially, which means that at the initial point we are able to reach the 0th index only. Right, so let's try to iterate over the array. It's less than nums.size. Yeah, so at this point what we have to do is the index that we currently at and the value present at that particular index. If we take the summation of those two values, so initially we are started from 0th index, so I will be 0, nums of I will be 2, so I is 0 plus 2, that will be 2. If it is greater than the maximum index that we have reached till now, then in that case we can directly update the max value, which will be I plus nums of I. So now it will be the value of max will be 2, right? And after updating it, we can check if the max value is may be greater than or equal to the last index of the array, and the last index of the array will be the size of the array minus 1. If this is the case, we basically have to return true, and if we have completed over the iteration of the array, then we can return false. This is very basic question for the greedy, like we are not doing anything complex here. So we are maintaining one variable to denote the maximum index visited till now, and if we are at a particular index, we take the summation of that particular index plus the value of that index, right? And if it is greater than the max value, then we update the max value, and after updation, if somehow we are able to reach the end of the array or maybe even greater than the end of the array, then we have to return true in that case. And if we have iterated over the array completely, we are returning simply false. Let's try to run this code. It is successful for this scenario. Let's run for this as well. Okay, for this case it is returning false. Let's see what's the issue here. So this is the array. It is 0, 1, 2, 3, 4. Let's create a max variable as well. Max will be initialized to 0. We are at index 0. The value is 3. So the max value initially will be 3 only. It was initially 0. Now it is 3. Now we come to 2. So I plus nums of I. 1 plus 2, which is 3. So it is not greater, so we don't update max. Now we come to this second index, 2 plus 1. It is also 3, so we don't update max. Now we come to this index, 3 plus 0, it is again 3, so we don't update. Now we come to 4 plus 4, it is 8, so max is getting updated. But there is an issue, we can't reach this particular index, this fourth index, because from the 0th index we have reached maximum till this point. From here as well we can reach maximum till this point. From here as well we can reach maximum till this point. So once we have come to this third index, we can't go to the fourth index. So we have to make one condition here. If max is less than I, then we have to return false. Max is I is 4 and max is 3. Yeah, correct. This should run. Correct. So let us try to submit this code. Yeah, this looks fine. And the runtime and memory usage are also fine. Yeah. So these kinds of problems are also useful to practice because they contain the concepts of arrays along with the greedy ones. And these are usually asked in the interviews because these problems seem simple, but it's very important to strike these conditions during the interview sessions. So keep on practicing these problems as well. And yeah, I will see you around next time till I come up with the next problem of LeetCode. So take care. Thank you.